In this video, we will start our discussion about inheritance and polymorphism. Let's start with the expected outcomes of the module. So after this module, you should be able to explain inheritance in Java, design inheritance structures in UML notation, implement inheritance structures in Java, differentiate between method overloading and method overriding, and finally explain and utilize polymorphism. So what is inheritance? Inheritance in Java is sharing attributes and methods among classes. We will have a structure consisting of a superclass, which is the parent class, and then we have some subclasses, which are the children classes. Now the superclass will pass the methods and attributes to all of its subclasses or all of its children. The child class, on the other hand, will inherit the methods and attributes from the superclass, and it can be a superclass as well. Now, note that a class can directly inherit only from one class in Java. Java does not support multiple inheritance, and the maximum number of classes you can inherit from in Java is one. Now you can have some sort of chain inheritance, so we can have class A that is a parent of class B, and then B is a parent of class C, and C is a parent of class D, for example. Now D can only inherit C at a time. It can inherit any class, but it can only inherit one class, so it's going to inherit C. But then if we look at the chain, so if I say I have an attribute, say attribute 1, and I have an attribute 2 defined on this, and on this I'm defining attribute 3, and on this I'm defining attribute 4. Now by default, B is going to inherit attribute A1, so it is going to have attribute A2, which is defined in B, and then it's going to inherit A1. And for C, it is the same case. It is going to define A3, but then it's going to inherit A2 and A1. And finally, for D, it's defining A4, but then it's inheriting A3, A2, and A1. Now, this is not just attributes and methods. Now, technically, what we said is D is inheriting all of those classes, but it's actually inheriting C, which is inheriting B, which is inheriting A. But can I say that class D inherits C, B, and A? That cannot happen in Java. There are some languages that will support multiple inheritance, but Java is not one of those languages. Now let's look at the UML representation of inheritance. Now in the previous slide, you've seen me drawing triangles, and the triangles are this simple right here, which is denoting inheritance in this case. Now this example has two classes, employee and part-time employee. Now the employee is the superclass, or we can also say the parent class, and this the part-time employee is the subclass, or what we call a child class. Now notice that each part-time employee is an employee as well. So there is what we call the is a relationship. So an object of this class is also an object of this class. So if I say I have fruit, and then I have apple. An apple is a fruit, so we can say this is the superclass and this is the subclass when we want to classify them. Now this is what we call the is a relationship. Now, the part-time employee is, as we discussed, going to inherit all of the features like attributes and methods from its parent class, which is employee. So we're defining a string for the number here. We're defining a string for the name. I meant by the number the employee ID. And we're defining the constructor. And we're defining a set name. That is a void method. We know it's a void because we don't have a colon and then a return type. We have a getter for the number, which is going to return a string. A getter for the name that is going to return a string as well. And then by this symbol, we're saying part-time employee inherits employee. Now, if I come to part-time employee, I'm defining the hourly pay, which is a double. Now, does this mean that employee will have hourly pay? Every employee will have hourly pay? The answer is no. Only part-time employees are going to have hourly pay. So whatever we define at the subclass level, which is this level right here, is going to be specific to that subclass and every other class that may inherit this subclass. So if we have a class here, this class will have access to all of those features and all of those features as well. Now we also have a constructor here that's going to define a string, going to take arguments as a string, and a double. So we know this double is to define this part, but these two strings are going to be passed to the constructor of the superclass to define those two strings. Then we have set hourly pay, like setters and getters, and then just a method for calculating the weekly pay that is going to take an integer and return a double or something. So this is how we display or represent the classes in UML notation. Now what about in Java? In Java we will use the keyword extends. So when I say class A extends B, this is how we define it. So we'll say public class, or like you'll have the access level, which is usually public. So I'll say public class A extends B, and then I will write my class in here. That means A is the parent class, or the child class, child class that's extending B, which is the parent class. So we have child extending parent. So in other words, I can read it like class A inherits B, or inherits class B, and this is the relation. So again, we will have the general syntax is access level class, and then we have the subclass, which is the child extends the superclass, which is the parent, and then we'll have the class body as usual. We will have some other things to put in here, like the constructor that is going to call the superclass constructor. We'll see this in the examples following this. Now a subclass will extend all methods and all attributes which are instance variables from the superclass, and if the superclass is extending yet another superclass, that superclass is going to have this set of methods and variables, and this is going to also be accessible to the subclass. Now we will use the keyword super to refer to the superclass. This is going to be used to access the superclass constructors and methods. So sometimes in a subclass there is a method or a constructor in the superclass. So you have the constructor of the superclass, supposing that this is B and A as we have in this example. So I have A here. I want to access the constructor of B. I will use the keyword super. And we will see how we can use this with constructors and methods in the next video.